All right, welcome. Today we're diving into something pretty fundamental in computer science, search algorithms. You know, the secret sauce that lets our computers find exactly what they're looking for in the blink of an eye. Seriously, have you ever stopped to think about this? You pull out your phone, you start typing a name, and bam, the right contact is just there. How on earth does it sift through thousands of entries that fast? Well, it's not magic, but it's close. It's a really, really clever algorithm at work.
And that's exactly what we're going to explore today. We're going to look at two of the most important methods for finding data: the simple, kind of brute force approach, and the super strategic, lightning fast one.
Okay, so first step is the method that we'd all probably use by instinct, the one-by-one approach. In the coding world, we call this linear search.
Yeah, the name pretty much gives it away, right? You have a list of stuff, you start at the very beginning, and you just check every single item in a line until you either find what you're looking for or, well, you hit the end of the list. Simple as that.
And this is just the perfect way to picture it. If you've got no system, no order, just a messy pile, your only option is to pick up the first book, check it, then the next, and the next. It's pure brute force, but hey, it gets the job done, eventually.
Let's watch it in action. Say we're looking for the number 12. Okay, we start at the top. Is it 5? Nope. Let's move on. Is the next one 8? Still no. How about the third one? Is it 12? Yes. Got it. Found it in 3 steps. And since we found it, we can stop right there.
So here's the bottom line for linear search. Its greatest strength? It's dead simple. Super easy to implement, and it works on any kind of list, whether it's sorted or a total mess. But its weakness is speed. That ON notation you see just means in the worst case scenario, like if the item is at the very end or not even in the list, you have to look at every single thing.
And you know that worst case scenario? It stops being a what if and becomes a huge problem when you're dealing with massive amounts of data. Suddenly, simple just isn't going to cut it anymore.
Just try to imagine your list doesn't have 5 items, but a billion. Like trying to find one specific user on a giant social media platform. Checking that one by one could take hours, maybe even days. It's completely impractical. We are definitely going to need a much smarter strategy.
And thankfully, there is a much faster way. But there's a catch. There's one special condition. To unlock this incredible speed, your data can't be that messy pile. It absolutely has to be sorted.
And this leads us to our second algorithm, the brilliant divide-and-conquer strategy, officially known as binary search.
So instead of plodding along one by one, binary search works by eliminating half of the remaining possibilities in a single step. It's kind of like playing a game of higher or lower, and believe me, it is ridiculously efficient.
You actually do this all the time without thinking about it. When you look for a word in a dictionary, say the word search, you don't start at page 1 with the A's, do you? No way. You crack it open right in the middle, land on M, and you instantly know to look in the second half. Just like that, in one move, you've tossed out half the dictionary.
Check out this example. To find 23, first we check the middle item, which is 18. Okay, 23 is greater than 18, so poof, we can instantly throw away the entire left side of the list. Our search area is now just 23, 27, 35. So we check the middle of that new, smaller list, 27. 23 is smaller than 27, so we go left this time. And there it is, 23, found in just 3 steps.
The power of binary search is just undeniable. It's lightning fast. That O log n thing you see, it's the math behind the magic of cutting things in half. Get this, to search a billion items, you only have to have the list about 30 times. 30! But, and this is the big one, remember the golden rule. The data absolutely must be sorted.
So, we have our 2 contenders, the slow but steady workhorse and the specialized high-octane speedster. Let's put them head-to-head.
All right, here's how they stack up. When it comes to pure speed, binary search is the clear winner, hands down. But linear search wins on flexibility, because it works on anything, sorted or not. And this really defines their use cases. Linear is for your small or messy lists, and binary is for the huge, organized ones. Here's probably the simplest way to remember the difference. Linear search is you, rummaging through that messy pile of books on the floor. Binary search is you calmly walking over to a perfectly organized shelf and grabbing exactly what you need.
So, as a programmer, or heck, even just as a curious problem solver, how do you decide which one to use?
Well, the rule of thumb is pretty simple. For a small data set or one that's a jumbled mess, just use the reliable linear search. But for a large and sorted data set where speed is everything, you always choose binary search.
And this is why all this matters. It's not just some academic exercise. Choosing the right tool for the job is the difference between an app that feels slow and clunky and one that feels responsive and, honestly, kind of magical.
So now you know one of the core secrets of efficient computing. It's all about that trade-off. Simple flexibility versus prepared speed. The only question is, now that you know, what are you going to build with it?